Welcome to this podcast series dedicated to the physical modeling community. We're here at Coastlab24, hosted this year by TU Delft. Enjoy listening. Broadcasting from the conference venue of Coastlab24 here in Delft. And I have with me Corrado Altomare from Universitat Politecnica de Catalunya.
Hello.
Welcome, Corrado. Would you like to introduce yourself and give us a bit of information about your background?
Yes, indeed. Well, I'm a civil engineer. I studied in Italy, and I have been working so far since my PhD, long time ago, already 15 years ago, on wave structure interaction and wave overtopping mostly. Both at experimental level, then in numerical model applied. Yeah.
What drew you into studying wave overtopping?
Do you want the real story? The real story is that actually they were building a new breakwater in my hometown when I was finishing my master, and I started to be interested in it and everything that was related to it. And overtopping was fascinating because it's terrifying if you see really, and this kind of stuff always also, catch your attention. So I started little to be interested in it. And then by chance during my PhD was for the first time published and presented to the audience, to the scientific world, the so-called European Overtopping Manual. So I started to know people, etc. Say, this is very complex and is cool and needs to be investigated.
Well, that's, I think, a beautiful story. But then, after studying wave overtopping, originating from a breakwater in your own hometown, is it difficult to go back and explain to, friends and parents maybe, what is wave overtopping and what are you studying?
Well, depend on the word. First time I show what I'm doing to my 5-year-old daughter. I brought her to our lab, and my words were, you see, Dad plays with waves. And so she remembered that. So, yeah, but about wave overtopping is a bit more complicated. But lately, unfortunately, all the events that we have, because we have a lot of flooding related to overtopping, there is climate change indeed. So people are starting really to understand, even in Mediterranean Sea, where I'm coming from, that this wave passing over a structure is a big issue.
So the main topic of your abstract for this Coastlab conference was about wave overtopping using a specific laboratory technique of measurements. That was bubble image velocimetry.
Yes.
Do you want to give us a bit of context about what exactly that is?
Well, the context is the following one. Nowadays we have to study wave overtopping also for our seafront, our promenade, in our cities, You are used to walk there, enjoy the beach or whatsoever, but now we have a lot of overtopping events. And the point is that what triggers, let's say, problems and damages or casualties, etc., is the individual event. So a mass of water that is passing by, it is passing through that and with certain velocity. So we have to quantify that velocity. To quantify velocity, usually to measure velocity in laboratory is not an easy stuff. We have several measurements. Some of them are intrusive, that they modify even the flow and have certain characteristics and problematics behind. So I started to dig a bit, and long time ago we used for the first time this technique that is called bubble image velocimetry. That in a nutshell is this: imagine that we illuminate the flow, where the flow is already with a lot is a breaking flow, no? It's broken already, and we see the bubbles, So we follow the bubbles. We use bubble as tracers, and correlating each frame, each images that we capture with the camera. Okay, so how the bubbles evolve and how they move in time, we are able to reconstruct the velocity of this bubble, and we assume, under certain hypotheses, that the velocity of this bubble is the same velocity of the flow. So this is important because at the end, combination of this velocity and the height of this flow will determine whether a person or not is stable, he falls down, he slides, etc., etc.
What is the bigger challenge in using that laboratory technique?
Well, the setup is very complex because the illumination, for example, the lighting is really a tricky part. You have to consider that you have to optimize the use of your camera, so basically your focal length, the resolution, the acquisition, so the sampling rate, but also that depends on the lighting that you have, the exposure that you have. So, for example, we did a lot of tests and trial and error, like, okay, the flume has, our wave flume has two glass walls, let's say, from one side and the other. So, first of all, the wall that is on the other side of the camera, I mean, we don't need a glass, we have to put something there. So we put an opaque sheet. Okay, white, doesn't work. Black, well, work better. Then we put a light on the back, works better or not, because we were acquiring data and then analyzing and checking the quality of our data. So at the end, that was a very tricky part. And also the point is that because we're speaking about bubbles, and it's something that we cannot really manipulate in reality. I mean, in the lab, so they will form. Then depend also in which facility you are working. So in my case, it was a very small facility, so there are other effects related to the bubble formation and the so-called scale effect and surface tension that might affect the result. Whether in a bit larger facility, you shouldn't have those effects. So it was quite, let's say, challenging from this point of view, but also the point of view of post-processing those data is complex, because you have to use a technique that was developed for something very similar, but not exactly the same. This is called PIV, that is particle image velocimetry. So you follow literally particles that are put inside the water, the so-called seeding, and you have to optimize that technology for your bubbles. That is not so straightforward, honestly.
Then my next question is, why did you use focused waves for this study?
Because the problem is related to extreme overtopping events. You know, when we design a coastal structure back to last centuries, at the beginning the criteria was to study the wave run-up. And then in the 80s, this criteria changed, and little by little we started to study the so-called overtopping and the mean overtopping discharge, something that in the 80s, Owens, that was the first one, says is very easy to measure, you know. A storm, you measure the whole water that is passing over the structure, you weigh that somehow, and you have a discharge. It's good, it's perfect. But now, little by little, we started to understand that we have to look at each wave that is passing over and each event. So, and the most extreme. So, focus wave is a way, very compact and fast, to represent just that extreme event. So, it's the idea of the project behind this talk and this presentation, that is a Spanish-funded project called Gloria, is that we want to optimize also the laboratory technique, let's say, or in order to represent this event. So using focus wave is a very good way because it's faster.
Then, if those tests could be reproduced in the larger scale facility, would that be possible? And how do you think the results would be altered?
The result will be different. Well, will be possible, of course will be possible. The point of large scale facility is that how large it is, and then the camera that you are using, and the lighting, and the setup. But assume that we can upscale let's say, the measurement setup. The difference will depend mostly to what I experience doing this test. Will depend mostly to the fact that we won't have problem related to the different, let's say, effect of the surface tension of the bubble. Basically, what is happening is that at different scale, the tension that you have, the surface tension that you have, affect the formation of the bubble, or the way they fragment, let's say. So the content of them, distribution of them. So this kind of force play a different role at different scale compared to other forces at stake. And in our case, in coastal engineering in general, the forces at stake are inertial forces, are very violent forces. So that will affect. So the content of the air, the distribution of the bubble might affect. Also consider, I told you at the beginning, that we are following the bubble, but we assume that the bubbles have the same velocity as the flow. That might not be true because the bubble, they can experience a strong buoyancy and maybe travel faster. So we have to carefully check that.
Do you think that modeling a similar setup in a numerical model in CFD could act complementary to this laboratory technique?
Of course, nowadays has to be like that. Hybrid modeling or digital twin is the way to go. I myself working already 12 years on a specific numerical model that is called, or numerical method that is called SPH, smooth particle hydrodynamics. And you have always to play with the two. Why? Because you need for numerical model still, and I believe we will always need a validation based on reality, so prototype or experimental modeling, because the physics are there. But the numerical model is a very, fast and cheap tool that can extend your experimental campaign or even be used for designing your experimental campaign. So the two stuff are going, to my advice nowadays, really in parallel, and this concept of paradigm of digital twin is taking place in any sector of engineering.
In this application, you used a promenade to measure the run-up. Would the same technique, the BIV, could be used in different types of structures?
No, it can be used in different types of structure for sure. The interest of this application, when I speak about promenade or sea walks, is because I'm looking to the urbanized area, no? So I'm not when people walk, when people enjoy, when you have restaurant, etc. No, I'm not looking to defenses of an arbor. That is a different issue. But in general, can be applied to any kind of wave structure interaction phenomenon. And more turbulent is the phenomenon, better it is, because we have to follow bubbles.
What do you feel that's the next step into applying this lab technology?
Well, the next step in my case will be to check it at a larger scale. In Barcelona, where I'm working, we are finalizing the construction of a middle-sized flume. We have a small one. When I did the test, we have a very large one of the first constructed in Europe. And in the middle one, I plan to do the same experiment to a larger scale to assess this actually scale effect. But beside that, what is the intention is that why do we need BIV? Why do we need the whole velocity field? Because as you said, we can then go to the numerical model. And if you go to numerical model has a great advantage. Give us every kind of information wherever we like, whenever we like. Okay, so we can reconstruct the entire velocity field in numeric and compare with experimental and then extend the numerical modeling. So, and with the extended numerical model, we have far more information to assess what triggers people instability, so what is related to real safety or coastal risk, if you like, speaking in general.
Well, we all know it takes a team to set up a physical model, run the tests and then analyze the results over the years, and especially when you make quality research. Yeah. Do you want to introduce us the part of your team on this project?
Yes, of course, because this project, Gloria, regardless of the fact that it's a Spanish-funded project, as a working team that is actually international. So first of all, of course, the collaborators from UPC, so Professor Xavi Gironeia, Joaquim Sospedra and Andrea Marcedu were fundamental to set up the model, to think, to conceive all the concept and to run the test. But then among all the, let's say, researchers that participate to this experimental campaign, we have Shui Chen from TU Delft and Van Noord. We have Professor Alison Rabi from Plymouth University. We have also the University of Bologna involved with Barbara Zanutic. So it's really a big team, and each one of us has his own expertise that help to then achieve the result.
Then my last question would be, what advice would you give to young researchers that go into the physical modeling world?
To enjoy it completely, make your hand dirty, work, learn, going to the field, that is also very good. Not just stick to the lab. And be curious a lot, and trial and error. Experimental modeling doesn't work when you push the button at first. It doesn't work. You always have problem, always. So what you have to do is that you have to be resilient and resistant and go on, and you know that you are going to solve all the little technical problem, and the world is not perfect, and you will start to understand little by little what you want to start.
I think that's a brilliant advice. Well, Corrado, thank you very much for joining us today. Enjoy the rest of the conference, and best of luck with your research in Spain.
Thank you so much.
This podcast was recorded during Coastlab24, the 9th Conference of Physical Modeling in Coastal Engineering. My name is Maria Sklia, and I hope you enjoy listening to this podcast series.